Hey, how's it going? Today we'll be continuing our discussion of natural selection. Basically, we'll be summarizing up from last week some ideas of exactly what is it, how does it work. Specifically, we'll focus on some of the types of selection. We'll focus on one example that we'll be focusing on in lab. This specifically has to do with bird beaks. And we'll talk about specifically how bird beaks have changed over time. Some of the other examples we'll also learn about, not this week, but in future weeks. We'll talk about the pepper and moss in a little bit more detail. And we'll also get into some of the evidence. Lastly, today we'll hit on speciation, or the process of making more species. So these are kind of the outline for what we'll be talking about today. So just to kind of recap from last week and do a little bit of review, what is natural selection? Remember, natural selection is the mechanism by which the environment selects traits or determines fitness. This in contrast to artificial selection. Artificial selection in which humans choose. And so this is something that's a little bit different. We're looking at natural selection where the environment's choosing. So remember, an adaptation is something that an organism connects to or fits with, and in this case, natural selection, we're looking at something for which an organism chooses to fit to. Recall there are 4 parts to natural selection. So last week we learned a little bit about the 4 parts. And those parts include things like variation, competition, overproduction, and survival of the fittest. Remember, variation meaning being different, and in clones, mutations cause the variation. Competition, fighting against others for limited resources. Overproduction, you're making more than you need. And lastly, survival of the fittest, having to do with being able to survive and have offspring. It's a two-edged sword. You need both things, being able to survive and have offspring. So now that we know a little bit more about natural selection, how does it work, we're looking for something called fitness. And fitness has to do with having kids and passing on offspring. So fitness is usually measured in how many copies you pass on. So for example, one individual has, let's say, one set of DNA. If they have a child, asexually, that child will be half their DNA. So fitness is measured then in half. So fitness should be the son or daughter. Fitness is ideal with clones, but the idea is fitness is also having to do with the fit. So if this person were to die, it would go back down to 0. So fitness is based on having kids that survive. And again, this is based on the environment. So, for example, just take a moment and list some traits. Some of the traits you might have listed were things like hair for heat. You might have listed something like thumbs. In certain environments, these could be advantageous, and in some environments, they would not be advantageous. The whole point of fitness is that you have a fit or a connection to survive in a certain environment. Specific environment. So it's the same issue that people always bring up with colleges. There's a lot of places where you could be happy, but the idea is that you would want one that fits the best. So it's the best fit. Humans, right? There's a lot of jobs that people could probably be happy with, but there's the one that they enjoy the most. That's the best fit. Puzzle pieces, right? There's only one fit. There's only one way it can go. Fitness is related to all this, and that you want to have a connection to the environment. And usually this has to do with getting food, shelter, having enough lifespan, and being kind of stress-free. So in some senses that may mean intellectual development. This could mean for mice being able to run around and being able to have toys and intellectual growth. So fitness, we're looking for being able to survive. and also have offspring. So within selection, we have kind of three main types of selection. Stabilizing selection, so we keep things the same. So if we had two phenotypes, for example, the brown mice, there's brown and white. Kind of keep things the same, and we kill off everything on the outside. That's stabilizing selection. Directional selection usually means new species, where we're picking an extreme and killing off the intermediates, and we're killing off one extreme. So it favors one extreme. Lastly, disruptive selection means we favor both extremes and we kill the intermediates. So this tends to be really common in new environments that are different. So evolution can work in 1, 2, 3 different ways by selecting different types of traits. You either keep things the same, stabilize it, directional, shift to the right or left, or disruptive, where you're keeping either extreme and killing off the intermediates. So there's also a type of selection called sexual selection, and it has two components in this. Males compete and females choose. So in male competition, sexual selection has to do with the fact that there are more males than females. And when that happens, males compete. That's a limited resource. So this will lead to things like horns, large weight. If you thought back to sea lions, right? They're huge and really heavy, so they could fight. Rams, they have horns, so they could battle for the females. This might also lead to things like peacocks, where they're really colorful and they're decorative, ornative. The whole point of the peacock is to show, look at how healthy I am, despite this disadvantage. It's kind of an oxymoron. I'm so good that I can survive without. The human example would be, for example, smoking. Why do people like the bad boys? Oh, man, it's because they're still alive, they haven't died, despite doing all these dangerous things like riding a motorcycle, and jumping upside down on the bed and drinking chemicals. That all has to do with this idea of male selection. So what does that lead to in females? It leads to females being choosy and being kind of, quote-unquote, picky. Because they realize that, hey, these males are competing, you can't just give your eggs away, right? You only have a few eggs. You can't just give away your eggs to the first, Tom, Dick, and Harry that show up. That leads to the pickiness of the females. These roles reverse when you have different amounts of the many and few. So if females have a few eggs, what must be this situation with guys? It's the opposite. So there would be many sperm. So this is a type of selection that also affects it, right? If females suddenly like a certain trait, it'll show up in the males. So females really drive sexual selection. So when anything cool ever comes out, twerking, Fast and Furious, the newest systems, the greatest new sport, it's all females drive this type of selection. So what's an example of all this stuff in practice? So we learned about Darwin, and Darwin went to the Galapagos Islands, and he looked at bird beaks. And he was also able to see that under different situations, you would get different types of beaks. You get big beaks or small beaks, and they were situated for different things. So small beaks, you could eat more food, but you preferred smaller seeds. The big beaks, they could eat any seed. So when would this be an issue? In a dry or wet year? That would influence what type of birds would survive, because again, the environment's changing. So the way you could always think of it is environment changes, organism changes. One cannot happen without the other. And then this week we'll also learn about some of the competition between the different bird beaks, between the big and small. Eventually only one will be able to win out, right? Because if the big can eat any seeds, but the small can only eat small seeds, Eventually, if it's a dry enough year, only the big bird beaks can survive. And we'll also look at different shapes in a little lab that we'll be doing this week. So kind of our last concept I wanted to talk about is speciation. So what is speciation? Just to break down the word. Species, right? A species is something that can mate only with itself. So myself and another animal, not human, are different species. We can't mate and have fertile offspring. So the whole definition of species is you're producing fertile offspring, meaning their sperm and egg can meet, you have the right number of chromosomes, they can come together, and that offspring can then have more of that same organism. So exceptions to this would be kind of your donkey, right? Or a mule, which is the cross between a donkey and a horse. Things like the liger, the lion, and the tiger, they will have an offspring, but it won't be fertile. And so speciation is extreme selection. And it's also assisted by isolation of populations, meaning you're by yourself. And when a species is by itself, it can lead to more kind of selection acting on it to keep it isolated and prevent gene flow. So this is kind of unlikely for humans now because we have all this technology, we have airplanes, we don't have any subspecies coming off. But this is more common in example for something like a bird, where, we have a tree, and we have a river that goes by. You can't get across that river, and so we have two populations growing. And that can lead to speciation. And that's kind of like the last kind of super extreme type of selection. There's also cases where selection does not play a role, which is not evolution, so there's no selection here. It's random chance. So random chance really plays a big role in how you came here today. And there's two of them. So genetic drift is the idea that you have random events. And so these would be things that could wipe out parts of your gene pool. It has nothing to do with it being good or bad. It's just being in the wrong place at the wrong time. So some examples of that would be such as a tsunami, earthquake. So there's an earthquake and half of the room fell in the hole. It had nothing to do with it being a better part of the room or better, smarter people. It was just chance events, a chance random event that could change the gene pool or the total types of genes in the environment. The other one is a founder effect. Again, we're also in this random change, but it has to do with moving to a new area. So this new area is usually something like an island. It could also be something like a forest that had been recently leveled by fire. The idea behind founder effect is that whoever decides to move might happen by chance. For example, if a bug floating on a stick, that's by chance. It might have drowned, it might not have mated, but that one bug can change the genetic composition of the new area it's moving to. So this is really important because you always want to have producers kind of move to your first area. So just a little review from last semester. So those were kind of all the points that I wanted to make today. So just realize that natural selection is the big one we talk about. But realize there are different types of selection, ranging from sexual selection, directional selection, stabilizing selection. Selection can create new combinations, including species. So this had to do with speciation. And that part of the lecture where you make new kind of things based on isolating the population. And having all these kind of mechanisms to keep things different. Lastly, I talked about when there is no selection, random chance plays a role. And so it plays a role in two things, genetic drift and founder effect. So that kind of wraps up what I wanted to talk about this week. We talked about selection, the types of selection, and what happens when it goes to extreme, which would be speciation, and what happens when there's no selection, such as random chance would take over. All right, so that's our lecture on evolution, natural selection, and some of the breakdown. If you have any questions, please feel free to email me, contact me, message me. Otherwise, have a great day, and I shall see you in class. Take care. Have a good one.